All right. Well, welcome to my stream, my screencast of round 1B of the 2021 Google Code Jam. A few people have asked to see my GVim RC, so it's open here. It's not nothing special. This is my process function that adds auto adds includes. That's the only interesting thing about it. So yeah, don't expect anything super special today. I'm pretty tired and out of practice, and yeah, ACM finals have not, or sorry, the ICPC finals have not happened in quite some time. So I haven't really done much in the programming contest field. So we'll see how this goes. All right, 3 problems. Fortunately, I'm not too worried about advancing, but we'll see. Hmm. Okay, well, that's nice that they've spared us some math here. um, okay, so at midnight, they will all be at 0 degrees, I believe. Well, if it were rotated correctly, but it's rotated relative to an arbitrary axis. Um, so there are too many nanoseconds to just try each one, which is probably the. I mean, that's probably what test 1 and 2 are for. Um, for test 3, oh, they're all visible. Oh, that's interesting. Okay, so if I get it correct, I'll get it correct. It's not even clear. I think there might be uh, multiple times that work, but I guess they're probably going to accept anything that actually satisfies the conditions. Okay. All right. So we can iterate over how many. Well, we can iterate over which hand we think is the hour hand and how many uh, times the minute hand has rotated around, I suppose. And then we can just check to see if the seconds hand corresponds to the same input. All right. Let's see how it goes. Um, want to be able to permute these easily, so I'll just read them into a vector. Okay. So we'll say h is equal to, oh, these should be 64 bits, probably. Oh yeah, this should be 64 bits too. All right, so we're going to try all the permutations of h, m, and s until we find one that works. And what we don't know is how many times the hour hand and the minute hand have gone around. All right, so so the thing that rotating the clock doesn't change is the difference between the minute and the hour hand, which grows at 11 ticks per nanosecond. So we want to use that. So int, so we want the total degrees. Well, the difference is going to be h plus nh times, these are so 120 billion ticks is 1 degree. Is that right? I was told that there would be no math. No, I'm kidding. Of course there's math. Oh yeah, right. This tells me. Okay, so let's see. So a full circle is equal to all right. So it should be the other way around because I want it to be positive. Okay, so the actual time is going to be see whether it's consistent with all of the given times, which means so that's the should be the other way around. I think these are the only conditions that matter. So as long as that's true, I think we're good. So that's the amount that we are rotated. And of course, this should be like just I mean, this should really just be I should really just do mod arithmetic on it. Just to make it positive, and so this is number of nanoseconds. The output is, yeah, okay. All right. Let's see if this works. Probably won't. Probably we'll have to do some debugging because this math is a bit annoying. Okay. Oops. Okay. I forgot to declare a prob. Whoa, what's going on? Oh, I forgot to. Yeah. Have to break out of multiple loops, which C++ does not make easy, unfortunately. All right, 0, 0, 0, 0, 0, 0, nope, 30, 0, 0, 1, 2, 3, 0. Oh, actually, maybe this actually is a valid solution for it. 630.00 or 0000. Zero 30 00 1 2 3 0. Wait, what's different from this? 0 30 00. Oh, okay. They explicitly tell us that these look the same, so that's fine. And test set 1 does not involve rotation. Okay, well, let's give this a try. I mean, since all the test cases are visible, you can see my tax returns. Let's see. Yeah. Since all the test cases are visible, then I might as well try. Save some time. Okay, well, that's done. Oh, that's interesting. They now have a sample passed thing. Okay, that wasn't entirely trivial, but whatever. It's done. Okay, subtransmutation. Ooh, alchemy. As the most skilled alchemist in your country, you need to make some rare metals. This is looking like a recurrence relation type thing. Interesting. Yeah, this looks a lot like a recurrence relation. This is what happens when you try to ask a mathy question like something about a recurrence relation, but you have to put it into real world terms. A constant problem I have when I'm trying to write finals problems, like, oh, this is a neat math problem, but how do I make it how do I do anything in the real world that resembles this problem? And often I fail miserably. Okay. So how do we solve this? So okay, that's a bit irritating. The visible verdict, the visible test case is not going to look a lot like the hidden test case. It's not going to be a good test for the hidden cases just because the A and B will differ. But as long as I write it without actually worrying about what A and B are, then I should be okay. So here's the interesting thing. We are actually given multiple metals. So if I were just trying to create one unit of one metal, it might be a little bit easier, but there will be leftovers when creating, there will potentially be leftovers when creating one unit of one metal. Okay, I think this is just, you have to assign an exponential value to metals. I think that's the invariant, is that if you assign an exponential value, well, you have to find the invariant. You have to find the formula for the value of each metal such that the transformation preserves that invariant. And so it's going to look, let's see. So it's going to look something like Vn is equal to Vn minus A plus Vn minus B for n greater than or equal to B. Wait, is there a metal 0? Yeah, there is not a metal 0. Okay, so if so n greater than B. Okay. So yeah, we want to assign, so this is the invariant that we want to tell us whether it's actually possible. Now, this might not be enough though, because you can't actually do fractional versions of this. This will tell us a necessary but not sufficient limitation on the size of the metal that we want. Okay, how about this? If I just start with one metal and then I do the transformation, so I end up with 1, 1, then I do the transformation again, and maybe I end up with 1, 1 with something that looks like this, and I do the transformation again, always greedily using the highest possible metal, then I will get a set of the metals I need are not large. And I think we have exponential growth working for us, so I think the number of iterations of this is actually not going to be that large. So I think we might just be able to simulate it. So yeah, so the only problem here is that we are not matching a single metal. We are matching a pattern, which means that we may have to actually stop. We might have to say, okay, let's presume that this is now the highest metal. We say that this matches. So say we've got 5 here and we needed 3 metals of it, right? So we can say, okay, let's stop here, pretend that this is the highest metal, but we still might need to do a few extra transformations in order to make the pattern below match. And again, we can do them greedily, but the thing is that we're going to stop at this metal. And yeah, I think that's all it is. So I simulate this. I just simulate the pattern, always starting from the highest, always transforming the highest thing. And then I keep on saying, okay, what happens if I stop here and this is the highest metal? Okay. I believe this will run in time because I think we've got exponential growth on our side here. So yeah, I mean, none of the numbers that they give us are all that large. We do have impossible. Wait, how do we get impossible? That I didn't realize. So if A and B are if A and B are not relatively prime, then that can make some configurations impossible. I could test for that explicitly, or I could just put a limit on the number of iterations, which I might just try doing. The only problem is there's a non-visible, there's a hidden verdict, which is going to possibly fail if I set that limit too low, and I won't know. I won't have any feedback that I set the limit too low. Although I should be able to see what the worst case is. Anyway, let's give this a try. So I think we have a plan. And if it turns out that the number of iterations actually is very large, I don't think it will be. But if that turns out to be the case, then I will have to rethink this solution. But I don't. My my head model is suggesting that that's not the case. We'll see. Okay. So this is just showing that it's not going to be trivial, and that n is actually the highest n, or sorry, the highest element is actually important. Let's see. So that's going to be my limit. I just need to remember that I've arbitrarily set that limit. All right. So first I will test to see whether this works. Do I need to use int64s? Better safe than sorry, actually. Because there is exponential growth here. I don't think it will actually grow out of the range of an integer, but it doesn't hurt to use int64s. So, yeah. I think I have an off by one error. Okay. Yeah. Actually, what I should do is start with I should always have cur at least as large as u. Okay. Don't really need this. This should be the other way around. Oh, I forgot to read in A and B. That's important. Okay. All right, so this is an adequate test of are we done? Now, yeah, I'll just do it the slow way. I'm never going to run out of metal, so I don't have to worry about the zero condition there. All right, I actually think this is sufficient. Let's see if that works. Four, 6, 5. Okay, so that's a problem. Okay. So we've got 5, 1, 2. We need 2 units of this and 1 unit of this. Oh, sorry, that's... Okay, for this one we need 3 units of this. Or we need 1 unit of this, 1 unit of this, 1 unit of this. And... do that. Four, 6, 5. Okay, that actually works. And okay, so this, I'm not actually outputting. And then I'm actually going to get overflow issues here. I don't think it's going to matter. If I overflow, it basically means it's impossible. But I will overflow. So that's interesting. Before I hit this 10,000. I don't think it's going to matter. Because overflowing will just make it harder because I will miss things. Yeah. Let me just make sure that that doesn't overflow. Just be careful. I don't actually think that's a problem, but okay. So that's good. Possible for 8. Ouch. At least that runs really quickly. In fact, I could probably just add a 0 to that. Yeah, actually, I'm a little worried. A little worried about runtime for 100 cases. There are 100 cases, right? Yep, 100 cases. Okay, well, back to debugging. Yeah, whatever. Okay. So we want 101. So that's metal 1, that's metal 3. Oh. Yeah, each time I do this, I need to add a rep. That's the problem. Am I off by 1? No. Okay, what am I getting wrong? Maybe that's where I need to add the rep. I should think about this for a second. Four, 6, 5, 5, 10. Okay, yeah, it looks like that works. Um, honestly, I'm not really going to have runtime issues for, well, I guess I will. I guess it'll take 20 times as long, potentially, for 19 and 20. So, yeah, 10,000 is probably good enough. Let's just try the worst case. The worst case is going to be 20, 20, 19, 20. And 402. All right, I think that's the worst case. So 10,000 is more than enough. And notably, there's no overflow. I mean, it's not even close to overflowing, which I didn't think it would be. It's only going to overflow if it's never actually going to work. So yeah. All right, I think I'm done. Just clean up the code a bit and all right, let's give it a try. Notably, unfortunately, the impossible case does not actually happen in test set 1. That's a bit of a concern. I'm actually not going to stress the runtime. 10,000 should be fine. What's the... Not even sure what the time limit is. Time limit 30 seconds for 100 cases. Yeah, 10,000 is fine. And I think that's an order of magnitude more than I actually need. Anyway, yeah, this is less error prone than trying to handle the case where the GCD of A and B is not 1. All right, let's see if it passes the visible. Uh-oh. Wrong answer. Okay, let me actually think about what I'm doing here. So every time I pop something off the top of this array, I am adding a rep, which basically means I have to shift the metals up 1 in order to match with the input vector u. And yep, I think that's right. Okay. So right now I'm looking at my excess here, or sorry, my test for whether it can match u at the moment, which notably is not the same as saying that all the values of cur are greater than or equal to the current values of u, because I do have to propagate this excess. Am I correctly propagating the excess? So what is a test case that actually tests? So what happens if I do this? Do I fail b.in? Yes. That's interesting. I actually get that it's impossible. Right. I'll only ever have two metals at a time. Notably, I don't even actually need this line. Always good to simplify, especially when you have a bug. Do I have exponential blow-up issues? That's the thing I sort of papered over. The worst case for case A is yeah, I really got that exponential blow up on my side. The worst case is just 29. Okay, what's the minimal case? That's fine. That's the no reps case. So I note that they're giving these out of order, even though you can greedily do it from top to bottom. Um, just to clean things up a bit, let's just do this. Let's just apply this limit. I mean, I'm cleaning up the code, but I'm not changing any of the functionality as far as I can tell, unless I have a bug somewhere. What am I missing? This is a problem. Normally I rely on the fact that when when the code just clearly matches my model, my mental model, it's usually correct. I'm trying to think of other test cases I can do. Well, this isn't good. I just want to see if there's any sort of, oops. Oh. Wait, why is this a long int? What the heck? Okay, I'm very confused by this. Huh. Weird. I should just make another input file. Okay. Huh? That's not equal to that. Oops. Ah. Okay. Yeah, that's not even close to overflowing. And these numbers look right for the overflow. I am modifying cur. That's, oh my goodness. I meant to copy cur. Yeah. I mean, I've even got this copy here. Oh, damn it. Ouch. I don't even want to upload this video. If you see this video, if I uploaded this video, then, well, whatever. I'll probably still upload it, but that is so embarrassing. So embarrassing. Oh my goodness. It's interesting that it wasn't caught by any of those issues. All right. Left in my vector2 string. Yeah, that's actually a subtle thing to catch because most of the time it will be doing transformations that are useful later. It just requires a specific setup of the input to actually make that necessary. Okay, well that was embarrassing. That was really, really bad. But anyway, people aren't done the entire contest. Oh, good job, Neil Wu. All right, and Igor. Yeah, Ericto. Ericto probably broadcast this. So yeah, watch Ericto's stream, not mine. Terrible. All right, let's see if I can salvage any shred of dignity from this last one. I mean, I'm sure I've qualified, but that's the problem. Like I upload these videos to the world, and so I have to do better than just qualifying. I have to look like I'm a reasonable competitor. I have to fool people. All right, n towers of b cubic blocks. An interactive problem. Okay. Um, but we do know that the incoming digits are random. Half the problem statement is just describing how to do the interactive process. That's the problem with these interactive problems. They're not nearly as easy to implement and test as the input-output problems, even if they are fairly easy statements like this one. Okay, so the thing about this is you don't know when the digits are coming. So you want to maintain blocks that are, or you want to maintain towers with b minus 1, just so that if you see a 9, you can place it as the most significant digit. Um, and I don't think you care that much about the digits. Well, okay, suppose you've already got, oops, let me just go to the whiteboard. Yeah, so you want to maintain at least one tower that's b minus 1. You're unlikely to get two in a row, two nines in a row, so you might not need to maintain two towers. So you might want a b minus 2 just in case you get, say, an 8, which you place here, and then you might want to keep some b minus 3 towers. Yeah, it's not clear exactly how many of these towers you're gonna need, and it's going to depend on how many digits are coming. I mean, we know how many digits there are. There are 20 times 15 digits. Um, yeah, like it seems like what you do with the top row is of paramount importance. Everything else sort of pales in comparison, especially since you only need 90% of optimal. 90% you can probably just ignore everything below the top level. For 98%, maybe not. For 98%, you might have to optimize 2 levels. Um, Wait, digit for each block is generated uniformly at random and b is equal to 15. Wait, is this not trivial? Because it seems like while building b minus the next b minus 1, you were almost certain to get a 9 for here. Not almost certain, but you were very, very likely to get a 9. On average, you're going to get more 9s than you can actually deal with. So I think that the solution where you just build towers of b minus 1, and then whenever you see a 9, you place it up there, I think that is probably going to pass test case 1. Now, for test case 2, maybe you have to... Wait, is it visible? Yeah, they're both visible. For test case 2, I suspect maybe you have to do something slightly tricky with this second set. Yeah, since you're going to get more 9s than you know what to do with, you can actually afford to take a few extra. So let's just pick some value k, and then we'll say that we will go up to b minus 2 for the first k, placing 9s as we see them. And then for the rest of them, we'll go up to b minus 1. Yeah, I think this solution in my mind has a pretty good chance of passing both test cases. We'll see. We'll see. Actually, prop doesn't matter. Okay, so let's set So I'm going to try various. I don't want to math it out. I'm going to try various possibilities for k. Let's say k is equal to 15. That seems like a good value. I think I have off by 1. No, this isn't quite right. There's a point at which I want to just start building everything to n minus 1. So we'll say 250. I mean, really, I can just take all this out. All right, nice simplistic solution. I don't know if it's actually going to work, but we'll see. I mean, I could futz around with like 9s and 8s and stuff like that at some point in the boundary, but I don't think I'm actually going to bother with that for now. I can tweak it if I don't pass the visible. Okay, so yeah, I don't think I need to bother reading this final integer. Okay. I mean, for later rounds, I will probably have to set this up early, just so I can get it to work. But yeah, I wasn't too concerned about this round. All right, less interactive runner. So I have to run this as okay. Expected one argument. Okay. Couldn't read a valid line. Tower number out of bounds. Right. Yeah. Where do I want to place this? I want to place this. Okay. Too small sum. Okay. What am I missing? The top block is the most significant digit, right? 1, 2, 3. Yeah. C error. Huh? What the heck is going on here? Oops. One. What the heck? Okay. Is it failing to read? This is an interactive issue. Oh. Huh. Boy, that's subtle. Okay. I should be reading this from the end. Okay. Cool. Now let's try different cutoffs. Okay, so let's try 200. What is the intended sum? So I've got, so just below 10 to the 18 and, oh, okay, so I need 9.12 or I need 9.37 and I'm getting 9.12. All right. It's even worse. Okay. So this is if the limit is always b minus 1. Then that's quite low. That doesn't even pass test case 1, I believe. This is the other extreme. Slightly better, but I'm still pretty far off from 937. Okay, so it looks like you do need to do something more clever. Maybe something with the 8s. Okay, so what is the expected number? So we have 15, a tower of 15. On average, we are going to get 1.5 nines per tower. So I can afford to put 8s on the second row of half the towers. Okay. But I need to make sure that I don't run out of towers. So I want a solution where I basically just throw 8s. By the way, I should copy this before I start mucking around with it, because it does pass the first test case. Okay. Yeah, so instead, I could do something like this. This is not quite what I have in mind, but it's an approximation. Oh, okay. Well, that worked. Okay. Let me just tweak this slightly. Too small. Correct. Too small. Too small. Correct. Okay. It's looking like 50% success rate. This is also looking sort of like a 50% success rate. Okay. Yeah, whatever. It's close enough. This is not exactly the optimal solution I had in mind, but we only need 90%. So we'll just submit until it works. That's why they made them both visible, I guess. This isn't the best way of solving this problem, but it is a good way with time pressure. I've gotten close enough that I can just fudge it. Wonder what happens if I set k equals 150. Nope. So I think a better solution would be to basically use context, like use how many nines I've placed so far and how far I have to go. Like right now, I'm sort of relying on things. I'm relying on enough of the sets to be just sort of well behaved and uniform that a single cutoff works. But yeah, for a more optimal solution, come on. Getting pretty unlucky. For a more optimal solution, I should be yeah, I should be using the number placed so far and making sure I don't cover up a B minus 1 tower that I would need. Actually, you know what? There's a simple thing that can probably make it more. Okay, it worked. What I was doing was I was adding a special case to make sure that I don't cover up a B minus 1 tower. In fact, why don't I just do that? Uh, so oh, okay, I thought that might do it, but no, it's still iffy. Is this test case right? So if and hj is equal to b minus 1. Yeah, I would have expected that to help. Oh well. So I modeled my way through that final problem, but that's okay. Yeah, this isn't exactly a red letter performance, but Obviously, I'm going to qualify. 55th rank. But, oh well. I don't know. I guess I could talk about my solutions. It's funny. The only the only hidden test set in this entire round is on one problem. So that's the only one that could possibly fail. I mean, I could, if this was a real contest, well, I mean, it's just a real contest. If this contest really mattered, I could work more on subtransmutation and, spend time making sure that it's exactly right and adding test cases and all that. But I, first of all, I have fairly high confidence in my solution, and second of all, it's just qualification round 1B. Even in some crazy situation where I somehow failed and didn't qualify, there's still round 1C, which isn't very likely. But anyway, yeah, congratulations to these top people who solved these blazingly fast. Even if I hadn't completely screwed up subtransmutation, I probably would have been probably still would have been like in the 20s. It looks like I'm not the only one who who has been fudging the final problem. Although Ericto got it first try. I wonder if his solution. I guess we can watch his stream and find out whether Ericto's solution was lucky or whether he had a better, more optimized solution than mine. Anyway, congratulations to everybody who slaughtered me, and I think that's it for this this recording. I will upload this screencast. And so I haven't actually looked at round 1A, and I haven't looked at round 1C. I might do videos where I practice them. I don't know. I mean, the problem with these videos is just people are acting like I am somehow, like, I guess in Codeforce's terms, a legendary grandmaster, and I'm not these days. I'm just not. I think you can learn from my experience. You can't learn from my current coding abilities and speed. So I don't know what the value of these videos is. So the value of the videos, it might actually be more valuable if I were to just talk about past problems and talk about, for instance, the ICPC finals and my experiences with that, and some of my problems in the ICPC finals. I have considered doing a Twitch stream, basically where I talk about ICPC problems. Honestly, I think that would be a much more valuable contribution than these videos where I sort of muddle through easy questions and don't get the hard questions. But yeah, we'll see. It's I'm still trying to find my place in the community as somebody who's not really involved in the community, trying to figure out how can I contribute. And I mean, I guess the real way I could contribute is if I actually got on Codeforces and started doing a lot of current rounds and being a real current competitor. But that's a lot of effort, and I don't have a lot of motivation to do that. So anyway, for the moment, I'll just keep doing these Google Code Jam screencasts. And thank you to anybody who's watched through to the end. I will see you in round 2. Bye.